Okay, so let's resume. So next, I'm going to talk about paging. So actually, this content was went over, so was gone through last lecture. But at that time, I don't have this Mac iPad Pro, so I don't have a way to explain by writing down some notes. So today I'm going to explain it to you, and this is relatively important for you to do your homework too. So last time we said that the address of a generated by CPU is divided into two parts, which are the page number and page offset. So no matter so here um, let's first talk about some concepts. Um, First, what is a page size? A page size is pretty much like what is the smallest unit of the memory space. So it is usually in the size of from anywhere from 1 KB to 16 KB. Okay, so so if you want to know how large is 1 KB, 1 KB is equivalent to 1024 bytes. Okay, so it means that any page has this. So if we have a page whose size is 1 KB, then it has 1024 bytes, and every byte needs to have an index. So it should starting from 0 to 1023 to 1023, and so we need to represent these numbers by using we need to be able to represent these numbers. To represent numbers, to represent a number from 0 to 1023, we need how many bits? To so in order for us to calculate the number of bits for this number representation, we can do an easy calculation, that is log base 2. So log base 2 1024 is exactly 10. So that is 1024 is 10 to the 2 to the power of 10. So here it means that, okay, to represent the address within the page, we need 10 bits. Okay, and then suppose that, okay, your operating so the virtual the virtual memory space, let's say, is 4 gigabytes. 4 gigabytes is if you 4 gigabytes is equivalent to 2 to the power of 32 bytes. Okay, it means that your operating system, so the virtual address can be represented by 32 bits. So of these 32 bits, so 10 of them is going to represent, okay, so the page is going to represent, we call it page offset. Meaning that it denotes, okay, how so at which location is it is in the corresponding page. And then the first part of it, which includes 32 minus 10 equal to 22 bits, are going to be used to represent which page it is. So that we call it page number. So this is the way for us to do the page number index. And so that is why we have this. Okay, if we have a logical address on a 32-bit machine and with a 1 KB size, a page number consists of 22 bits, while a page offset consists of 2 bits. So and then we can further divide the page table in the page table into two layers. So we have 12 bits to represent the we have we have the structure of the structure of the logical address can be 12, 10, and 10. So the structure will be like this. So we have two layers of page tables, and but um, I know this part is very complicated to and it's very hard for me to explain remotely. It would be much better if we sit in the same classroom and I explain it on the whiteboard, and at the same time you can ask questions to me. But this is relatively important for you, especially if you want to get a good grade in the final exam. Then I would suggest you to go over the book. For this is the second time that I ask everybody to read the book. So your task after this lecture, your task would be to read chapter 8.1 to 8.7. I strongly recommend all of you to read it because this reading will take you around 2 to 3 hours, but it's pretty worthwhile because they're very important for you to do your homework too. So your homework too is totally based on the lectures from today and from last week. It will be due in 2 weeks. It's like the next Friday. Take your time and stay healthy and safe.